Hello student, welcome once again your chemistry class. So last time discuss your different types of ligands. So last time you studied a polydentate ligand. Next is your ambidentate ligand. So it states that a ligand which contain two donor atom, but only one of them form a coordinated bond at a time with central atom or ion is called ambidentate ligand. So here example nitro. Here nitrogen to donate the electrons through central metal atom, and similarly in nitro group here oxygen atom is also donor atoms to donate the electron towards the central metal atom. So that's why they called as ambidentate ligand. Similarly here the thiocyanate and cyanide group that is also donates the here thiocyanate the S donor atom and is here nitrogen, so that's why they called as a isothiocyanate. And similarly cyanide group is your through donation of electron from carbon to central atom, that is why the cyano. And here the cyanide group through donation of electron from nitrogen atom, so that's why they called as isocyano. So next is your chelating ligand. This is also classification under the different type of ligand. When a bidentate or polydentate ligand. Here only use bidentate or polydentate ligand, not a monodentate ligand. When a bidentate or polydentate ligand use it two or more donor atom to bind a single metal ion, there a ring-like structure is obtained and it is called chelate, and the ligand is known as chelating ligand. I repeated, when a bidentate or polydentate ligand use its two or more donor atom to bind a single metal ion, then a ring-like structure is obtained. It is called chelate and the ligand is known as chelating ligand. You can see here some examples. So this is your chelate examples. Chelating ligands from the more stable complex than unidentate ligand. So here few examples of chelation, a chelating ligand. So there is a bidentate chelation, tridentate chelation. So here use a bidentate, that is your bidentate ligand, and tridentate chelation under your didentate ligand. So here one also ligand attached in the form of chlorine, so that's why they are called as a tridentate chelation. You can see here some example, that is a platinum attached with two chlorine and one your ethylene diamine. Here this is your bidentate ligand because two donor atom and they donate the electrons to central metal atom and to form a ring like structure. This is called your chelate and chelating ligand. This is your chelating ligand and this is your chelate. Similarly in a didentate chelation, here chlorine attached with this and didentate to form a didentate, and this is also your chelate ligand because they donate the electron to central atom. Similarly in case of tetradentate, you can see here, and when the chelates are more stable than the ordinary complex, and the stabilization of coordination compound due to chelation is called chelate effect. So next is your coordination number. Coordination number of a metal ion in complex may be defined as the total number of coordination bond formed by the ligand with metal atom or ion in the complex. This is known as coordination number. I repeat it, total number of coordination bond formed by the ligand with the metal atom or ion in the complex, this is known as coordination number. You can see here some example. So here total number of cyanide 2, that is bonded with a central metal atom or ion, is known as coordination number. So here coordination number is 2. This example is coordination number 5. In this example coordination number 5. In this example is your coordination number 6, because 3 molecules of ammonia and similarly 3 molecules of chlorine, addition of these two number 3 and 3 is equal to 6. So that's why they called as a coordination number of 6 in this molecule, in this complex. So next topic is your coordination sphere, counter ions or ionization sphere. All the terms are equal or same meaning of. So this statement, the central metal atom or ion and the ligand directly attached to it are enclosed in a square bracket and is collectively termed as a coordination sphere. But in case any ions are present outside the sphere are called ionization sphere or counter ion. Okay, I repeated. You all know that what is your coordination sphere, but in case of any ions are present outside the sphere are called ionization sphere or counter ion. For example, here take example, the coordination sphere like this, 3 positive, and the counter ion is your, this is your chlorine ion. Further here representation, this is your coordination sphere, this is your central metal ion, this is your coordination number for representation 3 and 3, this is are the two ligands, and this is your ionization sphere or counter ion because they are outside present in the sphere, coordination sphere. So that's why they called as a ionization sphere or counter ion. So next is your homoleptic and heteroleptic complexes. The coordination complex in which the central metal atom or ion is linked or bounded to only one type of ligand are known as homoleptic complex. But while the one in which more than one type of ligands are bounded to central metal atom is called heteroleptic complex. Here example, you can see here only one type of ligand attached to its central metal atom, that's why they called as homoleptic. And similarly in this complex you can see here two different type of ligands attached to with your central metal atom, so that's why they called as a heteroleptic complex. Okay, so thank you and have a nice day.